Okay, so I think I got this right now, but if I'm going to post this one, I want to make sure I have a topological conversation about using certain methodologies. I'm not going to beat up on A-level physics guy here about doing it while smashing bunny, but you lose a lot of paint inside of here. Not just off of the drawing technique, he actually has a really good one, but sometimes you get lost in that stuff as a teacher or market person dealing with projectiles like this, statistical analysis under the math, approximating gravity. Well, we're hopefully I do it correctly in this video here, and I'll show you the range is quite a bit different off of the approximation of 10 for gravity comparatively to 9.8 meters per second, and that total distance. It also affects in terms of theta here, sine, cosine. There's a few things in terms of what the information does about why it's 1/2. You'll actually see something in the mathematics as hopefully I do it for you here that'll show you why it is kind of that way. But let's get kicking.
This is V, this is theta, this is V sine theta, and this is V cosine theta.
You don't know what he's looking at. You could have it fixed out.
Components of the velocity V are V sine theta in the vertical direction and V cosine theta in the horizontal direction. And the point about that is that they act independently, and so you can calculate what is happening in the upwards direction or the vertical direction and what is happening in the horizontal direction entirely independently, and then you bring them together to get your solution, and I'll show you how. Let's take this situation here, and we will assume that V, that's the initial velocity of the ball or the bullet, whatever it is 20 meters per second.
I'm cool with that. It went about that.
We will assume that theta is 30 degrees.
Those are your new meters per second.
And we will assume that G is 10 meters per second squared. It's usually 9.81. But let's keep the math simple and
again,
call it 10.
You don't really know that that's 30.
And since we're going to need cos theta and sine theta,
what I mean is like,
we better just say what they are. The sine
if it's
of
90,
30
it's 90,
degrees is 1/2 or 0.5.
You're throwing a ball here.
And the cosine of 30 degrees is the square root of 3
again, why is it 1/2? Why are you killing these kids like that? It's great that you did that, but you don't need to do that. There is alpha nowadays. Use the internet to hit sine 30 degrees.
The vertical component of the velocity is V sine
30
theta.
degrees will get you 8.6.
Sine
you can
theta
change
is
those
V,
angles any way you want. You can
20
change
meters per
this
second,
velocity. Try to keep it in the wheelhouse.
times the sine of
throw a ball.
theta, which is sine of 30, which is 0.5.
That's a real throw
so
for you.
that's 10
Great.
meters per second, and that's the vertical velocity.
So this is the vertical velocity. We're just talking about
the horizontal velocity is V.
Okay, wait a minute. Let's go back.
Cosine
Make sure
theta,
we get that in there. Take it down by
which
parts.
is going to be V square root of 3 divided by 2, and that is equal to approximately 0.866.
That checks out on alpha.
So what do we know?
I'm okay with that.
The
but get rid of this,
vertical
get rid of
component
this, and
of
just
the
go
velocity
right to
is
this.
V sine theta. V sine theta is
You don't
V,
need this one.
which
He's
is
just stretching it
20
out.
meters per second, times the
Maybe
sine of
back down
theta,
there somewhere else.
which is sine of 30, which is 0.5, and so
We
that's
know the
10
assumption was
meters
20
per second,
times 0.5.
and that's the vertical
'cause
velocity.
That's what the V sine.
The horizontal
20,
velocity is V cosine theta,
and V cosine.
which is going to be V, which we said is 20 meters per second, times the cosine of theta, which is 0.866.
All right, well that checks out. All right, so far so good.
And that comes to 17.32
And that's again, this is not gravity.
meters
They are
per
close. You
second.
just killed.
So when you
everybody.
resolve this velocity of 20 meters per second at an angle theta, you find that that is equal to 10 meters per second vertical and 17.32 meters per
10
second
meters. That
in the
is
horizontal
30
direction.
feet.
Now, what is the vertical component going to
Wait,
do?
I know. That's one of those things you'll watch with those Newton-Kearley coulons coming up inside here. Make sure it's in the wheelhouse. That way the experimental, if I go trying to do that and it is so far off the farm that... So, you're throwing 20 meters per second. and it's in a range of 10 meters. So this is real close. You know, he is trying to keep that crate, and it would have been fine at that. But what that does up here kills you again. With just why that's that.
Well, the vertical component is just going to go up and back down again.
This thing right here.
Because gravity is acting in this direction, so the ball will slow, and then it will pick up speed and it will come back down again. And the question is, how long does it take to do that? And for that, we need the formula that V equals U plus AT. You'll find these formulae in my video on classical mechanics.
In a vertical direction for
V is the final velocity when the ball gets to the top, which is obviously zero because the velocity is zero and it then starts falling back down again.
And this is
U is the initial velocity, which is the initial vertical velocity, V sine theta, which is 10 meters per second. And A is, of course, G, which is acting in the down direction. So what we've got is V is 0 equals U, which is 10. And then it's plus A, but of course it's minus G because
I'm willing to live with that.
V is acting
I'm okay
upwards,
with that.
but G is acting downwards. So therefore, anything acting downwards needs a minus sign.
To gravity.
Minus GT. And that, of course, is 10 minus G we're going to call 10.
Okay, so he just rewrote the equation again, and now he's changing gravity all over the place. Now, 10 minus 10, G or T or whichever broken...
We said that we'd make it simple. So it's
Don't
10
use that
minus...
especially if you want them to, if they
G,
have to know this, you are just
T.
going to hurt yourself in the long run.
And that means that T is 1.
So he actually went G with there. So let's actually break that down, shall we? So what we have to work with here is, and we're going to change this over to, because 10 minus 10 is 0. It'll always be 0, but because it's not 9.8 meters per second, right, you can say, okay, so 10 minus 9.81 equals. All right, so that gives me a remainder here, 1 point, this right here, and that's in a second, right? That's this perfectly square bit as far as I can make out. That's what I kind of figured it out to be. So that's why it's 1/2 up there on sine or something. I know that has something to do with it. I'm not exactly totally sure of the mechanism here, but I know that has something to do with it. So we have to then say that's a double of it, or we got this out of 1 second. So what is 0.2? If you would have said 9.8, that would have been 0.2. That is out of 1 second. So what is 0.19 out of a second as far as I can make out here? I'm not exactly sure. So you minus it by 1 here. Minus 1 equals. So that's actually what this distance in time takes me. It takes me almost an eighth of a second, right? And then it gets into metrics because you're in meters per second, and it gets wildly in a hurry. But we want to change this over. We want to make this a whole, not the negative of what this is, because we know we just took 0.19 out of the second, which is weird, and you can't go the other way with it. But I think that's what's happening, because the numbers come up close enough, actually. What his answer is going to be 30 feet, 35 feet, and I'll get like 27 or 25 or something like that, which isn't too far off. But when you think about it, that's quite a big difference if that's 60 feet or whatever it is, right? You know, that's quite considerable. So let's process that through here. Again, I'm in there. We'll just make it 0.8 of a second. And now we want to multiply that by 2, right? Because it's up and down, which I guess that's the cosine half or 2/3 out of that thing. Anyways, you want to multiply that by 2. Okay, and that gets you a 1.6. And that seems about right. He's going to get to 2 seconds here.
1 second. In other words, it takes 1 second for the ball to get to the point where it stops.
That's
and
the
starts
stop
coming
point.
back down the other way.
This is
and of
breaking
course,
math
in
down,
exactly the same way, it will take 1 second to get back down to the ground again. So the total time
2.
for going up and down is 2 seconds.
But it's probably actually
Remember,
like losing energy.
the 1 second was the calculation simply to go from where it's fired to where it stops. Remember, we're talking just about the vertical component. We said that we can treat these two components entirely
making a bunker buster
independently.
bomb. What we have
So
is a
here we are,
Pulitzer barrel.
it takes 2 seconds. Now in those 2 seconds, the ball is travelling
Go on.
with a horizontal component which is equal to v cosine theta. And the distance that it will travel,
What's the name of that
distance
movie?
is
Code
always
Red or
velocity
Red October?
times
He's like,
time.
smoke this. Whatever.
So the distance is going to be velocity, which is v cosine
Oh,
theta,
we'll get there.
because that's the horizontal component of the velocity.
We've got the
Times,
vertical, and look at
t,
this
which
gravity.
is 2
We put it here.
seconds.
This is the
Now
gravity.
we
That's
worked out what the
what it's
cosine
doing
theta
apparently.
was. It's 17.32.
great. You know, when you're doing
So,
books like I've been doing the baseball
17.32
drills, so now I'm
is
thinking like, all right, how do you
v
move kids
cosine
around so they
theta.
toss the balls to each other in a figure 4?
Again, we
That's
said that
easier
d
to
is
track than
vt.
20 little
The
monsters
velocity
running
in this
around.
case is v cosine theta. So d is equal to v cosine theta. That's the
Of
horizontal
course,
velocity
tracking those
times
results for
the
the
time.
parents too. It's like
Horizontal velocity is
nuclear potato clock
17.32,
and
and the
kids'
time is 2 seconds.
Health
And that comes
and
to
biometrics for the school
34.
project.
0.64 meters.
Time out. That is nonsense. Let me show you. Okay, so we know the total value was 2 there, and we know that whatever distance we were looking for was 17.32. We were agreeing with that. That was up there. It works. That's fine. Nothing wrong with that. So now we multiply them. We say times 17.32, right? Equals 27 point. That is quite a bit difference. That's almost, what do you got there? 6, 7 almost. That in terms of meters, that's a big difference. If you multiplied that by 3, that is 83 feet. And it's not. That's 83 feet in 2 seconds, man. You got a cannon. I'm pretty sure you got a cannon. What is it, 60.6 feet to the baseball field? 60 and 6 inches. Oh, well, I already broke it. But, so that's something I want you to keep an eye on inside of here about, that being the distance may not be realistic in terms of how far you can throw a ball. 100 yards, about 3 yards in a feet, that's 300. That's a third of a baseball field, maybe. You get the football field out on it. It's, 70 feet from first base to second base. All right, in 2 seconds. That seems realistic to me. You know what? I can bite that. And maybe 34.64. 103 feet in 2 seconds. Maybe. It's in the wheelhouse. I'm questioning the distance. I'm pretty sure that gravity's gravity, and I'm pretty sure that the distance, after you've measured it, is the distance. But if all you had to go on was the angle, I'm gonna have me a question or two.
So that tells you that the ball will go a total distance of 34.64 meters.
Helped in some ways. He does more in here, and I gotta go through this.
Because in the 2 seconds,
in A-level physics,
the ball goes up and comes down. And after 2 seconds, it's there.